Mr. Adams.
Tangent lines, yes. Alright, so finding the slope in the tangent line. So let's look at, for example number 3, they want us to consider the function y equals x squared. And so I want to graph this so you can see what we're doing graphically. So if I take my graph and I'm going to draw a graph. When x equals 1, what will my y value be? When x equals 2, what will my y value be?
4.
Very good. When x equals 3, what will my y value be?
9. This is fun.
So I got to go up 3, and then I go 1, 2, 3, 4, 5, 6, 7, 8, 9. When I go up 4, when I go x equals 4, what will my y value be?
16.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then it's symmetrical about the y-axis. So if I come over 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 4. So this is what my graph looks like. I'm going to come through here. That's what my graph looks like. Now here's what I want to do is I want to find the average rate of change at the point 2, 4. So this is point P, and P occurs at 2, 4, and the textbook wants me to find the average rate of change at 2, 4. And so we've done this in the past by taking the limit by adding h to it.
This.
And so what we could do is the rate of change, remember that the rate of change is going to be delta y over delta x. And we look at our function and we said before that this will be the same as f of x plus h minus f of x all over h, right? And so then what I would do is symbolically I would say x plus h squared minus x squared all over h. And then if I push that through, I get h squared plus 2xh plus h squared minus x squared all over h. Now, what are we looking at though with regards to the x value? 2, 4. So wherever there's an x, what I could do is I could plug in a 2. So I've got h squared plus 2 times 2.
Wait, why do you have 2 h squareds? I don't think that's right.
Oh, you're right. There should be one of these should be an x squared. So this should be x squared. And so if that's x squared, this should be 2 squared. Good catch. And then minus h squared minus 2 squared all over h. If I clean that up, I get 4 plus 4h minus h squared minus 4 all over h. Okay? Well, this 4 cancels with the minus 4 on the end.
Wait, where'd you get -4? Oh, never mind,
Okay.
I wrote it down.
And so now if I factor out an h, I've got h is equal to 4 minus h all over h.
So,
Why does it say minus h? This should be plus.
so,
Okay? And so when the h's cancel, I'm left with 4 plus h. Now what is that referring to?
Rate of change.
So if I take 2 and I go over just a little bit, that would be 2 plus h, right? So I could say that this point here is 2 plus h, and the distance from here to here is 2 plus h. Well, right here I have 4, but if I just go a little bit over, which corresponds to the plus h part, I should have 4 plus h. That's what it's referring to. Now, it's actually referring to the slope. So depending on how much I put in for my h value, it's actually the slope is 4 plus h. So this isn't necessarily 4 plus h, but there's a corresponding part. But what I'm looking at is that the slope from here to here, on average, is 4 plus h. In other words, my rate of change is equal to 4 plus h. So whatever I choose h to be, that will be my average rate of change. If I choose h to be really small, like 0, my rate of change would be 4. If I let h be 0.1, my rate of change should be 4 plus 0.1 or 4.1. Does that make sense?
Yeah.
So now, if that's the case, if I take the limit as h approaches 0 of 4 plus h, I get 4, right? Because our goal is I want this h part, I want h to approach 0. This is the slope. Now a tangent line has this slope. So if I were to write a tangent line, my tangent line is going to be a straight line perpendicular to the curve. And it will look like this. It touches at only one point on the curve. Now how do I write that equation? Well, we know that the slope is supposed to be 4. So if I know what the slope is, and I know the point that I'm interested in, I could say y is equal to m times the quantity x minus x sub 1 plus y sub 1, right? Well, what point am I going to use? 2, 4. So I can write the equation of the tangent line by saying 4 times x minus 2 plus 4. Push the 4 through the parentheses, I get 4x minus 8 plus 4. If I simplify it, I've got 4x plus 4.
-4.
Minus 4, you're right.
3 pieces of candy.
Okay.
Now, this is the equation of the tangent line only at x equals 2. Only at x equals 2. Nowhere else will that line work. And that makes sense, right?
Yeah.
Does anybody have any questions?
Can we have a donut then? One is fun then.
3